So now we're going to do our transformations, but now we do them on a grid, which makes life a little bit easier, a little bit more straightforward. So for example, we know that a translation is like a horizontal, vertical slide, we like to think of it. So I want to take this polygon here, and what I want to do is I want to do a translation of it. I'm going to translate it right 3 and down 2. So on a grid, think of doing this. Think of taking this polygon and sliding it 1, 2, 3 to the right, and down 2. So this is where our 4 new coordinates are going to be. I'm going to have one here, one up there, and probably one right there. So that's the idea about what a translation does. A translation just slides each of the points. So that's all a translation really does, is it just slides it left, right, up, down, and you just move it in that direction. The fun things come when we do reflections and rotations. So on this screen, this is kind of what we're going to do in class. We're going to do a little investigation here where I ask you to figure out what the rule is. So we're just going to skip ahead to that. If you want to do the investigation, you can. So if we want to find out what these rules are, the first rule is going to take a point, any point x comma y, and it's going to do a reflection over the y-axis. That's what happens when you negate the x value of a point. And the second one is a reflection over the y-axis. I'm sorry, that's over the x-axis. When you negate the y value, it's a reflection over the x-axis. Rule number 3, when the x and y just switch the order of the coordinates, it's again another reflection, but this time it's a reflection over the line y equals x. So let's take a minute to think about what the line y equals x looks like. So it's a line that has a slope of 1 and a y-intercept of 0. So the line y equals x looks like that. It's a diagonal line through the origin that has a slope of 1. So rule number 4 is a reflection over the line y equals negative x. And if we want to think about what that line looks like, it's the same as the one above, except it has a negative slope. So y equals negative x, or y equals negative 1x, slope of negative 1, y-intercept of 0. The next one here is a rotation. And it's a rotation of 180 degrees with a center of rotation at the origin. So it's a 180-degree rotation centered at the origin. It basically spins your figure around. Now, this is sometimes also called a point reflection. And I'll show you later on why we call it a point reflection. Almost kind of sounds weird. Usually a reflection goes over a line. In this case, we can reflect through a point, perhaps, maybe a better way to say it. And our final one is a rotation of 90 degrees counterclockwise. Okay, so take a look at the clock and see the direction the clock is going. And again, it's going to be centered at the origin. So if you are a rules rememberer, then you kind of want to remember these rules here. I am not a good rules rememberer. There's some that I just plain old just forget. So I'll show you what I like to do on a problem like this next one. Well, those are all our rules. So on a problem like this one here, where I want to take a triangle, let's take a minute and graph triangle ABC. It has coordinates at A, which is at 4, 1. B is at 2, 6. And C is at 8, 7. Triangle ABC. So what we want to do here is we want to do some transformations in the coordinate plane of this triangle. So we want to graph what's called the double image. Notice it's A double prime, B double prime, C double prime. That's a little hint. That means that there's going to be 2 transformations going on. And as you can read, the first one is a reflection over the y-axis. So I'm going to do this one first. I'm going to do the reflection over the y-axis first. And once I get that, then I do my 90-degree counterclockwise rotation. So here's a couple little hints for you. So we do a reflection over the y-axis. Think about flipping this over the y-axis. If you do that, point A is going to kind of go over to there. It's going to go over 4 units away. Remember that when you do a line of reflection, or we do a reflection, the reflecting line is the perpendicular bisector joining a point and its image. So the y-axis is right in the middle of point A and its image, A prime. Likewise, B prime would be about here, and C prime is going to be about here. So here's our new triangle, A prime, B prime, C prime. And if you take a good look at it, it looks like you flip the blue triangle over and it lands on the green triangle. Not too bad. So I don't like to remember what the rule is. I just like to remember that a reflection flips something over a line. If I do that, I'm in a good spot. Now the second part is a 90-degree counterclockwise rotation centered at the origin. Remember, our rotations need an angle measure, a direction, and it also needs a center point. So I'm going to do something pretty neat here. So give me a second just to kind of set this up for us. I'm going to take all of that, and I want to take that red line, and I'm going to group all of these together to show you this idea of a rotation. Let's see. So now everything's together there. Good. So I got my grid together. So check this out. Here's what I like to do when I do my 90-degree rotations. I like to physically turn my paper 90 degrees in a counterclockwise rotation. And again, a counterclockwise rotation, 12, 11, 10, 9, it goes that way. So I'm going to physically turn my paper 90 degrees. Okay, and I'm going to stop here for a minute. So now the green triangle, which was my original, is now what my answer is going to look like. So the coordinates of A double prime, we'll do it in a different color, we'll do it in red. The coordinates of A double prime, which is like right there, I don't want to erase everything on there, there we go, is that point there. A prime is -1, -4, and I like to write them down. B double prime is where the green B is. And that's going to be at 6 or -6, -2. And C double prime is going to be at -7, -8. So now, once I turn my triangle and I look at this one here and I say, okay, well, this is my answer. I write down the points of my answer. Now what I'm going to do is I'm going to rotate it back, and I'm going to graph those 3 red points. A double prime is at -1, -4. There's A double prime. B double prime is at -6, -2. There's where B double prime is. And then -7, -8, which is right down here. So hopefully it looks like the red triangle is the result of turning the green triangle 90 degrees centered at the origin. That's how I do my rotations. I don't try to remember a rule. I turn my graph paper. I think that's the best way to do a rotation. Now, rotations and reflections don't have to be on like axes or the origin. What I want to play with is how to figure out problems like this one. How would you find the coordinates of point A after doing some of these reflections and some of these rotations? So we'll go through them one at a time. I'm going to bounce back and forth between this page and the next page, which is my grid paper. So I want to take the point -2, 5, which is right here at -2, 5. Let's call that point A. And I'm going to reflect it over the line y = 2. Y = 2 is a horizontal line whose y value is 2. It has a y-intercept of 2. So I'm going to do the same exact idea that I did before, where the line of reflection is the perpendicular bisector between a point and its image. So point A looks like it's 3 above that. Let me go 3 below it. There's my point A prime. It looks like it's at -2, -1. So again, rules are okay, but I like to look at it and graph it and do it on a grid. So in this case, this A prime is going to be at -2, -1. We'll write that down. A prime's at -2, -1. Okay, let's switch it up a little bit. This time, we're going to reflect over the line x equals 4. X equals 4 is a line that goes through where x is equal to 4. So this is the line x equals 4. Again, the line reflection, the reflecting line is the perpendicular bisector. So this looks like it's 1, 2, 3, 4, 5, 6 away. So 1, 2, 3, 4, 5, 6. So here's where my point A prime is. It looks like A prime's at 10, 5. So this time A prime's at 10, 5. Now the next one we want to talk about is that 180-degree rotation. And this is where I called it a point reflection before. Let me show you what I mean by that. So I want to reflect it through the point 2, 1. Let's call that point C for the center point. So here's the idea of a point reflection. I want to think, how do I get from point A to that center point? Okay, so I'm thinking I want to go like probably down a couple and then maybe to the right a couple. So if I do the same exact thing, if I go down a couple and then to the right a couple, this is where my point A prime is going to be. It looks like it's at 6, -3. So what you can see is that you're still doing a 180-degree rotation around that center point. But if you think about it on a grid, that point C has got to be the midpoint. So that might help you to visualize that. So let's see, we'll go back. We'll say that A prime, in this case, was 6, -3. Beautiful. Now our last one's a little bit trickier, but I think we're going to be okay with it. So the center this time is at 1, -3. Let me get rid of everything. I'll put point A back there. A is at -2, 5. Now I got the point 1, -3. I'm down here. That's my center point. So again, what I like to think about doing is, I like to think about how do I get from A down to C? Think of a 90-degree rotation like this. I want to find the point somewhere probably in here that makes like an isosceles right triangle. Because remember, a rigid motion preserves distance. So that length and that length will be the same. And that angle is going to be 90 degrees. So let's see if we can figure that out. Here's how I like to figure that out. So let's see, my point was at 1, -3 down here. So how do I get from A to C? It looks like I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, and then over 1, 2, 3. So what I'm going to do is I'm going to go in the opposite direction. Instead of going down 8 and then right 3, I'm going to go with the other way. So maybe what I'm going to do is I'm going to go left 8. Instead of going up or down, I'm going to go left or right 8. So let's go 1, 2, 3, 4, 5, 6, 7, 8. And then let's go down 3. 1, 2, 3. So if you think about this point right here, I'm going to call that my point A prime. And again, this idea of an isosceles right triangle comes up. So let's take a look. Does it look like those two distances are the same? And does it look like I have a 90-degree angle at C? That's how I do my 90-degree rotation. So A prime, let's see, that looks like it's the point -7, -6. So this A prime's at -7, -6. So I really like to do my things on a grid. whether they're over origins and y-axis and x-axis, or if I have to do them over different lines, kind of drawing them out a little bit. I like them so much better than these rules, I'll be honest with you. So I'm hoping that you find this graphing just as much fun as I do.